Find a unit vector that has the same direction as the given vector. The given vector is negative 3i plus 7j. I'm going to give this vector a name. Let's go ahead and call this vector A. And we can represent it that way. We can also represent it in component form as negative 3, comma 7. Now, we want to find a unit vector that has the same direction as this vector. So what we're going to do is, first of all, find the length of the vector A, and then divide the vector A by its length. That'll give us a vector in the same direction, but with length 1, and that, of course, is what we mean by a unit vector, a vector of length 1. So the first thing we have to do is find the length or magnitude of A. That's going to be the square root of the components squared and added together. So the square root of negative 3 squared plus 7 squared, which is the square root of 9 plus 49, or the square root of 58. And then the unit vector, which we'll call something clever like U, that is in the same direction as A, the vector A, but of length 1, because that's what it means to be a unit vector, have length 1. We're just going to take the vector A and divide it by its length, divided by the square root of 58. So that's going to be equal to, let's say what we're doing here first, taking the vector A, dividing it by its length, and so that is the vector A, which is negative 3, 7, divided by the square root of 58. This is really like scalar multiplication, multiplying by 1 over the square root of 58, and so we can think of this as negative 3 over the square root of 58 in the first component, 7 over the square root of 58 in the second component. Or, if you like, we can write it using the standard basis vectors, negative 3 over square root of 58 times I, plus 7 over the square root of 58 times j. Clearly, this is in the same direction as the given vector, and it is length 1. If you take the first component and square it, the second component and square it, and add them together, take the square root, you will get 1.